Dynamic electric vehicle charging, or DEVC, is a groundbreaking technology that has the potential to eliminate range anxiety, one of the current barriers to adoption for electric vehicles. Well, my name's Michael Kisson, and I'm Director of Engineering here at Qualcomm New Zealand Limited. We have a strong focus on R&D. We are inventors, and that's what's enabled us to get where we are with the wireless charging technology. We're very much part of a global team. We have engineering offices in San Diego, Switzerland, Shanghai, and of course our main office in Munich. The team has worked very hard the last few years to develop a solid, robust, and fit-for-purpose dynamic charging system for electric vehicles. It's been very satisfying to take it from a concept design right through to a practical demonstration system. The Qualcomm Halo technology takes a full systems design approach. So we have technology that speaks to the power conversion, the magnetics, the control and communications, but also the ancillary systems and safety. We split the project into 3 phases. First of all, the concept design and prototyping here in Auckland, and then the industrialization and manufacture in Munich. Finally, the installation and testing at the Fabric site in Saïtery near Paris. For the initial concept phase here in Auckland, we needed to demonstrate that the stationary systems we'd developed were going to be extensible to the dynamic scenario. For that reason, we used the stationary systems as a starting point and developed a few dozen concept designs based on those, using different system topologies and magnetics topologies. Each of those was simulated, and the results were assessed based on fitness for purpose, as well as the cost to implement and install. Well, to assess the performance of the final prototype system, we needed to build a rig that was going to allow us to test it in a reliable and repeatable fashion. The rig is a 40-metre long section of road on which we have a trolley that acts as a car. And the trolley is able to simulate different vehicle heights above the roadway, positions across the roadway, and different vehicle speeds and accelerations. The rig has enabled us to do several thousand hours of testing for the prototype system. So once we had completed the concept design in Auckland, we provided the designs through to the engineering team in Munich, who produced the hardware. It was about this time that the Fabric project was getting started. The goal of the Fabric project is to assess dynamic electric vehicle charging from a social, financial, and technological perspective. Fabric's a large project. There are 25 consortium partners. So the industrialization involved the engineering team in Munich. They looked at it from a cost optimization perspective, as well as making sure that it would meet the environmental demands of being installed at Fabric. The demonstration track at Fabric is a 100-metre section of purpose-built dynamic roadway. On that section of roadway, we also have 2 fully integrated electric vehicles that we can use for testing and demonstration purposes. For maximum flexibility and reliability, we made the system as modular as possible. So the roadway is split into 4 subsections, each of which is 25 metres long and has an independent power supply. We call those stubs. Each stub supports 14 submodules, which we call base array networks or band blocks, and those are a piece of magnetics along with some power conversion circuitry. The band blocks produce 85 kHz magnetic field, which is transmitted to a nearby vehicle. The vehicle pads pick up the magnetic field and convert it to DC power for the vehicle. The initial testing of the system was with 1 vehicle, but when that worked so well, we weren't satisfied. So we've now had 2 vehicles charging simultaneously on the track. Well, the results of the testing have been really excellent, and we've demonstrated the ability to power the vehicle at 20 kilowatts while it's moving in speeds in excess of 100 kilometers an hour. It doesn't matter if the car is going forwards or even in reverse, you're still able to get power. We operate a licensing business model. We license the technology to automotive Tier 1 suppliers and infrastructure companies who will design and manufacture finished product fit for purpose. We fundamentally believe that regardless of the magnetics topology, access to Qualcomm Halo technology is important for anybody designing or building a wireless charging system that suits automotive OEM requirements. The ideal future scenario is seeing the dynamic charging rolled out practically and installed on highways around the world. Imagine driving down a highway and at the same time having your vehicle picking up charge. Or potentially a slow-moving line of traffic, for example a taxi rank, where the cars can be moving forward and again at the same time picking up charge. Maybe a Formula E race. In real time the driver can decide between taking the racing line or moving slightly to the side and picking up additional charge. Now these might sound like science fiction, but they're possible using the Qualcomm Halo dynamic wireless charging technology that we've developed.